Okay, so welcome to the first Ethereum meetup in Lisbon, Portugal. My name is Justin Wu. You can follow me on Twitter at blockchainlsheesh. And today I'll be giving a presentation called An Introduction to Bitcoin, Blockchains, and Ethereum. Okay. So I'd like to thank Premium Minds being the sponsor and host of this event. Premium Minds, a premium software house located in Lisbon, Portugal. Okay. So what is Bitcoin? So just a quick show of hands. Before today, how many of you have heard of Bitcoin? Okay, so basically everyone in the room. Great. So another show of hands, how many of you have heard of blockchain or know what that is, blockchain? Okay, almost everyone as well. And another quick show of hands, how many of you have heard of Ethereum before today? Okay, so less people. Okay, great. All right, so we'll do a quick rundown of Bitcoin, what it is, and then we'll get to the blockchain technology and then specifically Ethereum. So Bitcoin, it's digital money that you can send through the internet. You all know that already. And the cool thing about it is that it's transferred directly peer-to-peer without going through a middleman. So you don't have to go through a bank or clearinghouse or any of this. That means it's decentralized. And this fancy word here, disintermediation, just means you cut out the middleman. Okay? So as a result, fees are much lower. It's usable wherever there's an internet, so you don't have national borders. And your account cannot be frozen versus fiat currency. I mean, if your bank doesn't like you for some reason, they could just freeze your bank account. And this has been shown to happen. You know, people like Assange, you know, they have a difficult time getting banking. Can't be done with Bitcoin. Sending Bitcoins is similar to sending an email, in the sense that when you send Bitcoin, you digitally sign a transaction, just like when you send an email, you send it from your personal email address. And nowadays, you can actually purchase mostly anything with Bitcoin. Overstock.com accepts Bitcoin, Microsoft accepts Bitcoin, and thousands of vendors across the world accept Bitcoin nowadays. Yeah, and it's money. So let's talk a little bit about the core technologies behind Bitcoin. We have primarily public and private key cryptography. So those of you who work in encryption will know that public and private key cryptography has to do with the creation of two keys that are paired, one of which is public that you can give to other people, and they can send you encrypted messages by encrypting the message with your public key, and only you, who holds the private key, is able to decrypt the message. And the way that it works in Bitcoin is that your public key makes part of your public Bitcoin address, and in order to send funds, in order to send your Bitcoins, you need to hold that private key. A cryptographic hash function, which is something that takes an arbitrary amount of information and it puts it through this hash function, and it will digest it and put an output of fixed length. So this is important when you're building a database. And peer-to-peer networking. So computers link together in a network. And my own conspiracy theory is that Wadeye's B-Money plus BitTorrent could have been the idea for Bitcoin. We all know what BitTorrent is. And the blockchain, which is what we'll talk about later. And then also the system behind validation of transactions, which is called proof of work, or how to solve the Byzantine generals problem. And those of you who work with fault tolerance, mixed signals in a network, how to distinguish between which signals are legitimate and which ones are potentially signals generated from an attacker who's trying to attack your system. Proof of work solves that problem. Okay, so what's the big deal with Bitcoin? Why do people even care? So Tim Draper of DFJ Venture Capital says banks are hugely threatened by Bitcoin. And that's kind of easy to see, considering the fact that if you are the owner of your own private keys, which you are in Bitcoin, you can essentially be your own bank. You have the authority to send and receive funds, and you don't need anyone else's permission to transact. Okay, so this is hugely threatening to banks. Mark Andreessen, one of the co-founders of Netscape and a venture capitalist, says that Bitcoin is like the internet in 1994. And the reason he says this is because in 1994, the internet was young, and we couldn't even think of things like social media or other technologies coming out of this platform. It's such a new platform that the really killer applications haven't even been invented yet. That's Mark Andreessen. Patrick Byrne of Overstock.com says, money is too important to leave in the hands of government. The long-term value of fiat currencies tends to go to zero, which is true. I mean, fiat currencies generally only last 200 years. And if you look at this chart, the purchasing power of the US dollar from when the gold standard was abolished has essentially dropped like a rock, while the Federal Reserve is printing money like there's no tomorrow. So I mean, do you really want your hard-earned money to just continually lose value and purchasing power over time? No. Okay, so this is not possible with Bitcoin. So the supply is strictly capped at 21 million coins by the year 2140. Supply only increases by 25 coins every 10 minutes as rewards go to miners for securing the network, and we'll talk about mining. Bitcoins cannot be printed out of thin air like fiat currency. You actually have to work to generate them. And it's what I like to call proof of work versus proof of violence. So proof of work, when you create Bitcoins, you have to prove that you have put in computational work in order to generate Bitcoins. Whereas the US dollar, it's a coercive money. I mean, the US government or the military coerces you to use that, and we've seen that based on the various wars overseas to prop up the petrodollar. So all of this technology, Bitcoin, is based on blockchain. Okay, we'll explain what that is. So blockchains, transactions, and miners. Oh my. Okay. So blockchain is a fancy term. You might not have heard of it before, but essentially, it's simply a database for recording transactions, one that's copied and updated for all computers participating in a network in what is known as a distributed ledger. So think of it as an Excel spreadsheet. We're all familiar with this technology. Imagine as if all the computers in a network had the same copy of the Excel spreadsheet, and they all had to agree on the contents of the spreadsheet. And if anybody wants to make a change to one of these cells, all the other computers have to agree that this change is legitimate. So what are blocks? A block in a blockchain are just like pages in a book, different pages in a ledger. Blocks also have things called headers for metadata, such as the hash of the previous block, and content, such as transactions. So participants called miners, this is a Dogecoin miner, participants called miners verify blocks and reject illegitimate ones in the process of proof of work, which is what I talked about earlier. This process is computationally difficult, and it requires time and electricity and real-world resources, so these miners are compensated to do that with newly minted Bitcoins. Each block is linked to the previous block in a chain all the way to the first block, all the way to the genesis block. So that's why it's called a blockchain. So the advantages of a blockchain: it's secure, because using a blockchain is cryptographically secure. The ledger is distributed across the network, meaning that hacking is near impossible. So in order to hack a blockchain, you would have to gain control over 51% or more of nodes in a network, which is extremely difficult and expensive. Transparency, all transactions are recorded and available for scrutiny. You have low counterparty risk, meaning that no party can transfer assets such as money or authority or property rights that they don't already have. And transactions that are executed are not revocable, versus fraud. I mean, blockchains can eliminate most, if not all, of the fraud that involves not paying or not holding up your end of the bargain in a deal. And things like chargebacks on a credit card can't happen on a blockchain. Okay. It's decentralized, so no single authority has control. So no one actor can come in and say, okay, well, I want to change this. I want to change all the parameters, change the rules of the game, versus the Federal Reserve. Okay. The Fed can basically toy with the interest rate and mess with the economies of people all over the world, and you can't do that with a blockchain-based currency. It's decentralized. No one person has single control. Privacy. When you set up a Bitcoin wallet, you don't need to provide your name, address, phone number, blood type. You don't need to provide your credentials beyond your node address. So versus your local bank, where you do need to provide all that. And a low transaction cost. If I wanted to move $1 million in Bitcoin, it might cost me 10 cents or something like that. Whereas if I wanted to move, for example, $40 from my bank account, or 40 euros from my bank account here to my bank account in the United States, that might cost me 40 euros. So why would I even do it? I mean, a real world example, I received a check from my bank in the States for $9.58 or something. I couldn't even cash that check here in Portugal because the fee that the bank charged me would be more than the amount on that check. So I just ended up tearing up the check. I mean, the low transaction costs versus of Bitcoin versus Western Union or PayPal. Western Union is notorious for charging 12% remittance fee for countries like Uganda, other countries where you have high risk. They charge 12%, which is huge, versus Bitcoin, which charges a few cents per transaction. So blockchain, in summary, it's a single source of collective truth. Everyone agrees on what everyone else has in a decentralized manner. It's a common ledger that all Bitcoin or Ethereum users share and agree on. It's secured by mining, mathematical proofs, proof of work, to validate legitimate transactions and reject illegitimate ones. And the key term here is consensus. Everyone agrees on who has what, no middleman extracting fees as a trusted third party. So, the blockchain, the trust machine. And yes, this is the cover of Economist magazine. The Economist says, the trust machine, how the technology behind Bitcoin, which is blockchain, could change the world. And this is a big deal because the Economist magazine is all over the world, very well respected publication. A lot of movers and shakers read this on a daily basis. So when the Economist says that the blockchain is the trust machine, it's kind of a big deal. So who else cares? I mean, who cares about blockchain technology? I mean, is it just this pie in the sky thing? No one's really heard of it? No one really cares? No. People do care. Business decision makers on the boards of every Fortune 500 company are essentially mandating their technologists to understand what the blockchain is and how it can affect their business. This is Andrew Keyes from Consensus, which is a Microsoft partner firm. Microsoft recently launched on their Azure Enterprise IT Solutions platform Ethereum blockchain as a service, which allows companies to use blockchain tools without having to run a full Ethereum node. So Microsoft is getting into this, so they care. Mark Walport, the UK government chief scientific advisor, says that distributed ledger technologies have the potential to help governments do many things, like collecting taxes, issuing passports, generally ensuring the integrity of government records and services. Wow. I mean, this is the UK government's chief scientific advisor saying that the blockchain can do all of these things. World Economic Forum says 10% of global domestic product to be stored on blockchain technology by 2025. So let that sink in for a little bit. I mean, what do you think 10% of global gross domestic product is? That's about 10,000 billion US dollars to be stored on the blockchain by 2025. Not so far away, folks. Only 9 years. Okay? And this is the year that it'll start. Blockchain will become a reality in 2016. Eric Bashini from Deloitte. So what does this mean for application developers? Those of you who develop applications. What does it mean? And if you're looking at the blockchain now, you got to think architecture. And what's the difference between Napster and BitTorrent? I mean, Napster got shut down in a heartbeat because the government didn't like them, but more importantly, it was a centralized server architecture, so the government knew where to attack. Just go to the guy's house and take his hard drive, right? Versus BitTorrent, the government and the Recording Industry Association of America has been trying to take down BitTorrent with billions of dollars worth of attacks and lawyers, and yet it still is alive. Why? Because it's a distributed network of nodes, and you have this distributed architecture. So businesses with large data silos, blockchain can reduce your costs and increase security. Governments with various branches that don't necessarily talk to each other, like Mark Walport said, you can streamline interagency cooperation and information sharing to ultimately serve the public better. I mean, why doesn't Finances talk to Seguridad Social here? I mean, why when I log into my Finances website and trying to do my taxes, do they ask me how much I paid in Social Security deductions in the year? Like, shouldn't they already know that? I mean, aren't you guys all the government? I mean, the blockchain could really help streamline these processes. Okay? So, Bitcoin is awesome. Yeah, we all know Bitcoin is awesome, but the problem is that it only has one function, which is currency. Proof of work is very wasteful. I mean, it wastes a lot of electricity. It destroys computer hardware because it's constantly running all the time. And what if you wanted to do more with blockchain technology? Enter Ethereum, which is what we'll talk about mostly today. Ethereum is a planetary scale computer built on blockchain technology. And they just came out with their Homestead release, which is their production-ready platform. And it is a blockchain application platform. So what is it? I mean, it's a decentralized platform that runs smart contracts. So smart contracts are applications that will run exactly as programmed without any possibility of downtime, censorship, or fraud, or any other kind of third-party interference. So, planetary scale computer. It's open for all to use, which means that you can download the Ethereum client and you can start using it immediately. There's no infrastructure. If you're an application developer, you want to deploy an application, you usually have to put a lot of resources into that. You have to rent a server farm, or you have to put a lot of actual hardware into that. With Ethereum, you just need to know how to code. It's Turing complete, which means that you can build arbitrarily complex applications, ones that could potentially run forever. and we'll talk about that. Talked about that. The main thing with Ethereum is that you have the Ethereum virtual machine, which runs on Ether, which is the crypto fuel that allows smart contracts to run. In order to run applications on Ethereum, you have to pay per computational step using Ether. Okay. So the key innovation is the Ethereum virtual machine. So what is it? It's a Turing-complete virtual machine that's accessible from anywhere in the world and has a number of benefits for the automated economy. What do I mean by the automated economy? I'm talking about machine-to-machine interactions in addition to human-to-machine interactions or human-to-human via machine interactions. So we're talking about things like your refrigerator ordering food for itself, for you, when it notices that you're low on milk. Okay? Things like that, automated economy. The Ethereum blockchain is a blockchain with a built-in programming language. Now this is important because if you remember, a blockchain is like a database that's distributed all throughout the network. And the Ethereum network itself is like the server. When you add in a built-in programming language, you have a distributed global computer, which is what we talked about earlier. Okay? So it's a decentralized, massively replicated database where the current state of all accounts is stored. Okay? And it's a consensus-based, globally executed virtual machine. Okay. So, continued. The Ethereum virtual machine handles internal state and computation. So states are stored on a distributed global ledger, the Ethereum blockchain. So a state could be whether a smart light switch is on or off. A state could be how much the balance is on a particular account in a wallet. A state could be who owns what in real life. It could be smart property. Who owns what? Computation is paid for with Ether per computational step. So this is what balances the system being Turing complete. Because of the fact that you have to pay per computational step, it prevents the system from getting bogged down. Because, yeah, sure, people could write an application that just prints hello world, hello world, hello world a million times. They could do that because it's Turing complete and it would run forever. However, it would be prohibitively expensive because you would have to pay for each hello world that you print with Ether. So the economics of the system allow it to be quasi-Turing complete. So it's a large decentralized computer with millions of account objects, and each account object has its own internal code, which allows it to be a smart contract. It executes itself. Contains a 32-byte key or value database called storage, so you can store information in there, and it can call or send messages to other objects. And so when we go back to the fact that that we talked about the automated economy, because these objects can call or send messages to each other, they're autonomous in a way. You have machine-to-machine interaction, and it's an automated system. So, Bitcoin versus Ethereum. Really easy analogy. Bitcoin is like a pocket calculator. I mean, it really does one thing very well, just adding and subtracting balances. Okay. Versus Ethereum, which is like a computer. It's a globally distributed single instance computer that everyone has access to. And the reason why it's so disruptive is that this is only a single application. This is a generalized computer that has potentially unlimited applications. And so, just like how the smartphone replaced your pocket calculator, or your laptop replaced a bunch of different other machines that you had, the Ethereum virtual machine has the potential to disrupt a lot of single-use applications out there. Okay. So with Ethereum, you can build unstoppable applications. So because it's a distributed system with smart contracts that execute themselves, no single actor can go in there and say, okay, well, this has to stop. I mean, the Ethereum programs will run and run and run as long as they have Ether and as long as the network is live. So write immutable, self-enforcing smart contracts. And we'll talk about what smart contracts are in a few slides. Pay for play. There are no centralized servers or worrying about uptime, which is huge, because if you are an application developer and you don't have the resources to deploy a huge server farm or something like that, you don't have to worry about that. You just have to worry about knowing how to code and funding your smart contract or application with Ether. You can access new and once impenetrable markets. And Ethereum is sometimes defined as a world computer, which is accurate, but its core value proposition, I would say, is that it's a generalized platform for marketplaces where individuals can adopt various roles and freely participate in economic interactions. And the reason that is because Ethereum is a generalized platform that has a lot of different applications within that platform. And through using that application, or through using this platform, you can build a reputation that you can take with you to various other applications within that platform. Because right now, you might have a certain level of reputation on Facebook, you might have a different reputation on Twitter, you might have a different reputation on Instagram, whatever. However, on Ethereum, no matter what applications you use on Ethereum, you can take all of that reputation with you. Again, it's programmable money. I mean, what can you do with programmable money? Money that you can program to do things. It's a good question to think about. So one of the building blocks of Ethereum is a smart contract. So think about it. I mean, what if a contract could enforce itself without the need of lawyers and governments and courts and people with guns? What would happen? I mean, you have a meat space handshake, right? What are smart contracts? I mean, they're pre-written logic or code stored and replicated on the blockchain, self-executed by running the code, and it can do things like force the code to make payments, to update the blockchain. It can transfer ownership. Okay. So everything that a contract can do, it just does it automatically. So essentially, when you sign a contract with somebody, you're saying that you're transferring ownership of something. But maybe does that happen automatically? Well, no, not in some cases it doesn't. So with a smart contract, breach of contract is not possible from any party once the contract is live. Once the code is there, it's on the blockchain, it executes itself given certain conditions. So the disintermediation factor, or the cutting out of the middleman factor, is high. Okay? So lawyers who work with contract law should be paying attention to this. So let's go into some real world use cases here. Ethereum plus smart contracts plus devices equals, can anyone guess? No? I'll tell you, the Internet of Things. Okay? So there's a really interesting company called Slockits, which is an Ethereum company, that says if you can lock it, we'll let you rent, sell, or share it. So when you think about a device that has a smart lock, in this case, SLOC stands for smart lock. Okay. If you think about it, you can program a lock to open or close itself depending on if it gets paid a certain deposit. And the use case here would be home automation. You could rent your mostly unused property, such as your flat or your car. So you have a smart lock on your door, and it's essentially air